Hey guys, we are going to do our section 4.1 notes today. You are going to be doing your own notes based on the text for the vocabulary box as well as our section 1 notes on angles. Please be thorough. Make sure that you include all the notation and give yourself some drawings, color code it, all of that stuff. Let's go ahead and start. When you're ready, go ahead and start on section number 2. It says radian measure. So what radian, actually, before we do radian measure, I want to do section 3, which is degree measure, which we're more familiar with degree measure, and then we'll come back to radian measure. Remember, degree measure is a full circle is 360 degrees is a full circle. So a full revolution around a circle corresponds to 360 degrees. A half revolution, so half of it is 180 degrees. We talk about that a lot just in life and sports and flips and spins and things. But in order to convert degrees to radians, which we'll go back to it, but a radian is another way to measure an angle where if a circle has a certain radius length, if I take this purple segment and I lay it right on top, that's equivalent to a radian degree measure. So the angle that opens up to this much on the circle is called 1 radian. So to convert degrees to radians, we simply we're going to multiply our degrees by pi over 180, oops, not 180, pi radians over 180 degrees. So the degrees are going to end up canceling out. And to convert radians to degrees, we're going to take our R as in radians, and we're going to multiply by 180 degrees divided by pi radians. So let me show you how to do that. To convert 120 degrees to radians, we're going to use this here. So we're going to take our original 120 degrees and multiply by pi radians over 180 degrees. When I do that, degrees divided by degrees cancel. I know 120 and 180 can divide by 10, cancels out the 0. And 12 over 18 can reduce by 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. So what I'm left with is 2 times pi radians all over 3. So 120 degrees is equivalent to 2 pi over 3 radians. And to convert 9 pi over 8 radians to degrees, again, we're going to take our radians, which is 9 pi over 8 radians, and multiply by 180 degrees all over pi radians. So when we're looking at this, I know pi divided by pi. Also, this is technically radians. So I know radians divided by radians cancels out. I'm going to cancel 8 and 180 can reduce both by 4. So I get 8 divided by 4 is 2. 180 divided by 4 is 45. And I'm left with 9 times 45, which is 405 degrees all over 2, which is 202.5 degrees. So I know 9 pi over 8 radians is equivalent to 202.5 degrees. So if I'm looking at a table of just like really common degrees, I know 0 degrees is equivalent to 0 radians. Let's do the most common ones. I know 1 pi, we've been using this as a lot, is 180 degrees. Half of that is going to be pi over 2 or 90 degrees. I know half of that again, so half of 90 is 45, so therefore half of pi over 2 is pi over 4. And then if I keep in mind that 1 pi is equivalent to 180 degrees, I can see that pi over 6 is really like saying if pi over 6 is equivalent to 180 divided by 6, which is 30 degrees. And same thing here, pi over 3 is like saying 180 degrees divided by 3 is 60 degrees. And then 270 degrees is like, well, I know if this is 270, that's 3/4 of the circle. So I know that's 3/4 4/4 pi. We can write that as 3 pi over 4. Let's go back to section 2, which is the radian measure. The measure of an angle is determined by the amount of rotation from the initial side, which is like the starting side. When we're talking about angles, usually we say this is the initial side, which is equivalent to 0 degrees right here, to its terminal side. So if this is the ending part of my angle, the measure of the angle goes from my initial side to my terminal side. 1 radian is the measure of the single angle theta, which is a Greek letter, we call that theta, that intercepts an arc, which we call S usually, which is equal in length to a radius, which we know is R, on the circle. So for example, if this is my circle, that was not a good circle. Let me try a better one. There we go, there's a perfect circle. And this right here, whoops, this is R. I'm gonna take that length of my red and I'm going to put it right on here. That length as it lays on the circle, we call S. Okay, algebraically, this means that theta is the arc length divided by its radius. So this here is theta, where this here is R. A central angle of 1 full revolution is equivalent to the length of 2 pi. We'd have to have 2 times pi of the radius to get all the way around the circle. The radian measure of 1 full revolution is also known as 2 pi revolutions. A half a revolution would be half of 2 pi, which is 1 pi radians. And a quarter revolution would be half of a half, which would be pi over 2 radians. And 1/6 revolution corresponds to pi over 3 radians. Angles with measures between 0 and pi over 2, we call them acute, because in our circle, if this right here is pi, that's 180 degrees, and this is pi over 2, where this is 0, I know any angle in here is going to be where it's acute, because it's going to be less than 90 degrees. And anything that's past that here, any angle that's here, is going to be between 90 and 180 degrees, and we call that obtuse. To find an angle that's coterminal with a given angle, we simply add or subtract a full circle, which would be 2 pi radians, to theta. And you can do this multiple times, or a multiple of 2 pi, which just would mean, you know, a revolution more than once, to theta. So let's say for example, I wanted to say if theta equals negative pi over 8, and I wanted to find a coterminal angle, I can add or subtract 2 pi, which is a full circle. So negative pi over 8 would look like this. If this is my initial side, 0 degrees, negative pi over 8 would look something like this. I want to know what other angle could be coterminal with that. I know I could find this. So I'm going to add 2 pi. 2 pi right now is over a denominator of 1. Let's multiply that by 8. We get negative pi over 8 plus 16 pi over 8. And if I add these up, I've got 15 pi over 8, which is a coterminal angle to negative pi over 8. So negative pi over 8, it's also the same location as 15 pi over 8. How do we find the supplement of pi over 4? So remember, supplement means adds up to 180, or pi radians. So if I want theta to be, if theta is pi over 4, I know theta plus its supplement equals pi. So I'm going to say pi minus theta equals my supplement. So pi minus theta. Right now, in order to subtract this, I'm going to make a common denominator by multiplying and dividing by 4 on top and bottom. So we get 4 pi minus pi is 3 pi, all over the common denominator of 4. So our supplement of pi over 4 is 3 pi over 4, because when you add them together, you get a full 180 degrees, or pi. And lastly, our linear and angular speed. So this is a really great application of central angles and radii, where we can calculate the speed. This really applies to cars and how fast a car can go, because we're talking about speed, and a car rides on a circle called a tire, right? So for the circle with the radius r and a central angle where the arc is s, s is given by r times theta, where theta is in radians. Note that if the radius is 1, then s just equals 1 theta, and the radian measure of theta equals the arc length. Consider a particle moving at a constant speed along a circular arc. So let's say here's a circle and you've got a particle and it's literally moving around this circle. So a particle, we talk about this in chemistry when we're talking about like motion of atoms. We're talking about how those particles will move. To find the linear speed. So our linear speed, we're going to use our formula, which is the arc length divided by time, or the arc length as s over t is time. And usually it's in seconds, but sometimes it's in minutes or hours. If theta is the angle and radian measure corresponding to the arc length s, then the angular speed, so this we don't care so much about the size of the circle, but we're talking about how fast are we changing the arc of the angle. That angular speed is the central angle divided by the time, otherwise known as theta divided by t. So let's do an example. If you've got a 6-inch diameter, 6-inch diameter gear that makes 2.5 revolutions per second. So starting here, I know this is 1 revolution, 2 revolutions, and then a 3rd revolution, right? So 2.5 revolutions around the circle per second. So here's what that means. If I want to look at the angular speed, I'm going to use my formula. Angular speed equals theta over t. Well, in this case, our theta is 2.5 revolutions times a full circle. Well, I know theta equals 2.5 revolutions times 2 pi radians, which is really 5 pi. So I'm going to use that up here, 5 pi divided by t, which is 1 second. So I know that my angular speed is 5 pi per second. That's it for now.